So hello everyone, welcome to the Women in Network Science seminar. I'm very excited to introduce today's speaker. So she is Jennifer Watling Neal, is an associate professor of psychology at Michigan State University, and she's looking into intersecting the fields of developmental psychology, education, and social networks. And her research aims is to understand how social networks are associated with health and well-being in public school. So I'm very happy that you accept our proposal of being here. And thank you very much, Jennifer, for being here and giving this talk. So I'm going to just hand it over to you.
Thanks so much, Francisca. I am so excited to be here kicking off the spring Women in Network Science seminar. I've been following the WINS group on Twitter and in other venues for quite some time, and I'm a huge fan. And so it was really flattering and honoring to be invited to speak with you today. I am a professor of psychology at Michigan State University. And today I'm going to be talking about measuring signed networks in preschool, and in particular, sharing some key challenges with you, and then also some potential solutions to those challenges. Oops. And just a little bit about me, Francisca mentioned this. My overarching research goal really focuses on understanding how social networks are associated with health and well-being in public schools. So I've been doing work in social networks within public school contexts, ranging from preschool all the way up through kind of high school. For about the last almost 20 years now. Have a lot of experience in that. And my work really focuses on 4 different streams. And I just wanted to give you a little overview of those 4 different streams before we talk specifically about preschool. One stream of my research is really focused on how social networks can help educators promote youth well-being. And here I've typically been focused on kindergarten through 12th grade public schools, really looking at teachers and how their advice networks might support implementation of evidence-based practices, but also principals and superintendents, so educational leaders, and how their advice networks might help them access information about evidence-based programs to adopt in their schools. That's one line of work I have. Another line of work that I have has really focused on perception. And here I've used cognitive social structures developed by David Krackhart and looked at teachers' perceptions of classroom relationships, so kids' classroom relationships, and also students' perceptions of those classroom relationships. And I've really been interested in both teacher and student attunement to classroom relationships. So to what extent do they agree with each other, and to what extent do students agree with the consensus of their peers, and what sort of predicts that? So that's another line of work that I have. A lot of my work, probably the bulk of it, has focused on the role of context in youth behavior and traits. Here I've looked at kids as young as preschool up through middle school, really looking at things like how network position might affect things like kids' aggressive behaviors or selection and influence processes on temperament traits. And oftentimes I've used things like stochastic actor-oriented models here to look at selection and influence. And then finally, I'm really interested in advancing both social network theory and methods within the context of developmental science. So I have a really strong interest in data collection methods. I'm trying to improve data collection in these contexts, and also I'm trying to find new ways to analyze data that's collected specifically for understanding how kids' networks develop. And today, the focus of my talk is really going to be on these latter 2 streams of research. However, I'm always really interested if there are other people out there who are doing network research within the context of schools and want to chat about the other lines of research that I have. I'm always excited to hear from you. So please feel free to follow me on Twitter or email me and tell me about work that you're doing as well in these areas. So for today, the topic of my talk is really going to be focused on a key question. how can we overcome some key challenges to measuring signed networks within the context of preschool? And I'm going to be doing a couple of things. So just to give you a little bit of a roadmap to the talk, first, I'll talk about why preschool networks are important to understand, what the state of the literature is on preschool networks, and what the key challenges are to measurement in networks. And I'll be raising some key challenges and then trying to present some solutions to those challenges. I should point out too, before I get really started on the talk, that if you do have some questions as I go along, any clarifying questions, feel free to put them into chat. And I have chat up, so hopefully I'll be able to see those and answer them as we go. I'm hoping to leave a lot of time for questions as well, so we have some time to chat, and I can answer questions. And also I'd love any of your feedback on some of the work that I'm presenting today, because some of it is new. So just starting with why preschool networks are important. So in the US context, where I'm based, I'm here in Michigan, where it's currently snowing, so it doesn't feel much like spring. But in the US context, preschool attendance is really, really common. So we have 40% of 3-year-olds in 2020 attending preschool. And by the time kids are 4 years old, the majority of them are attending preschool, 60%. And this is also true in other countries. So in the European context, we also see a lot of children attending preschool. And what's interesting about preschool compared to other school contexts that I study, when you get into elementary school and middle school and high school, the day seems to be very structured, right? So kids are really engaging in a lot of instructional activities throughout the day. There's a lot of teacher-led activities. But in preschool, activities are really a lot less structured. So they tend to be structured around play. And they're sort of, and in some ways they're sort of unstructured, in that kids have the opportunity to kind of be in the classroom. They get to choose their own activities. They're not really guided by the teacher so much, and they oftentimes get to also choose their playmates. And so it makes it a really interesting time to look at social relationships. Preschool is also very interesting developmentally, because this is the period when kids begin to engage in more coordinated and in more complex forms of play. So kids move from this period from solitary play into more dyadic play oftentimes, and then into triadic and larger group play. They also tend to start to engage in more coordinated and complex forms of play. So oftentimes what we see in preschool is kids might start with something called parallel play. We're going to be talking a little bit more about parallel play later in the talk. Parallel play occurs when kids are kind of playing next to each other, doing the same activity, but they're not actually necessarily talking or engaging with each other. And in preschool, we see them move from that type of play to social play, where they're actually actively engaged in conversations with each other, coordinating with each other, and maybe engaging in things like pretend play. So it's a really rich period for the development of social relationships. It also provides novel opportunities for the formation of both positive and negative ties. So in preschool, we start to see kids form likes, other kids that they like and want to play with, friends. And we also see them start to form dislikes, kids that they don't want to play with, that they might want to avoid. And so this is an interesting period. It's really the first time that kids might be able to engage with same age peers beyond their siblings. So their network just sort of instantly extends during this period. And preschool networks exhibit lots of interesting structural network features. So we know from prior research that even at this age, you see things like triadic closure, which we see in most social networks. Finally, at this age, preschool networks are associated with lots of interesting outcomes for children. So I've done some research looking at personality traits, and we know that there are selection and influence effects on personality traits as young as 3 and 4 years old. There have also been some really great studies on preschool competency, and we see influence effects on preschool competency. So kids' play relations actually impact their school readiness. So it's a really interesting period. It's an important period to really understand social networks. So given that it's an important period to think about social networks, we can ask what the state of the literature is on preschool social networks. How much research is there out there on this age group? And to answer that, I want to talk a little bit about the history of networks in developmental science and where we've been heading. Actually, network research has a very long history in developmental science. So sociograms were first used by Helen Hall Jennings and Jakob Moreno to map classroom relationships way back in the 1930s. So what you see here on your left is a sociogram. This is actually from some older kids. These are fourth graders. And it has a structure that is very akin to what I might see today if I collected a fourth grade network. You have usually a couple of components, and one component that's mostly boys, one component that's mostly girls, and a couple of ties between gender. And we'll talk a little bit about gender homophily patterns a little later in the talk as well. So we've been using these techniques for a long time in developmental science. And there's also been a recent expansion of these network techniques in developmental science. So here, these are just studies, number of articles on the y-axis here, and years on the x-axis, ranging from 1987 all the way up to 2019. And what you'll see here is that studies using ego networks or personal networks have remained relatively stable over time. We've always kind of seen these studies in developmental science, but they've sort of remained stable. But whole network studies, there's been a huge expansion in whole network studies in developmental science, especially since 2011. You can see the inflection point of that line there. We've seen sort of a recent growth in these studies, especially as we have dynamic network techniques that can help us unpack selection and influence effects in developmental work. But we can think about this growth. How much of this research has been done on preschool, and has any of it at all been done on signed networks, so networks that both include positive and negative relationships? And I'm just going to present a recent paper that I wrote that was a systematic literature review of network methods in developmental psychology journals. These are studies that were published in high-impact developmental psych journals. The questions of this review really focused on who network data were collected on, what types of network data, what types of network relationships, were collected, and how network data are collected. And just to give you a little overview of what I did and what was included in this literature review, I've got a Prisma diagram here that I'm going to walk you through. So in terms of the inclusion criteria, I did a Google Scholar search here, and I looked for articles that were appearing in developmental psychology journals that were somewhat high impact, so they had to have at least an impact factor over 2. And I looked for a couple sets of keywords. So they had to include the word social network, and then they had to include at least one of several other sets of keywords that might indicate that they were doing some sort of network analysis. And that yielded around 787 articles in the initial pool of articles that I looked at. So the next thing I did was screen abstracts, and I took those 787 articles, looked at the abstracts, and was able to eliminate around 40 more articles, either that weren't empirical, that didn't include any sort of network data or analysis, or that weren't really looking at kids or the adults that serve kids. But I still had 747 articles that I really couldn't tell, and I had to go to the full text for those articles. By doing that, I was able to eliminate an additional 78 articles that didn't have any empirical network analysis, another 457 articles, so a lot of articles that were using these terms sort of metaphorically. So they were talking about social networks, but they weren't actually doing a network analysis. And then another 11 articles that weren't focused on kids or the adults that served them. And so I ended up with 201 articles, and of those articles, 16 were ego networks and 185 are whole network studies. And so I'm going to present some results of this, but I want to first preface those results with the limitations to this particular review, and that all systematic reviews have potential issues with coverage. This systematic review is no exception. So again, it focuses only on articles published in high-impact developmental psych journals, which means that it's going to miss some developmental work that's published in other places. And some of my favorite journals, like Social Development or Social Networks, for example, publish a lot of work on kids. So this review doesn't really include those articles. It may miss articles that don't use the selected keywords that I had, and it's limited to the period prior to February 2019. So we've continued to see growth in network studies within developmental science. So moving to our questions here, if we look at who network data were collected on in these studies, the vast majority of articles included data that were collected on adolescents. So the bulk of developmental science work that uses networks focuses on the period of adolescence. So papers focused on early adolescents, 10 to 14-year-olds, 78.1% of the articles included in my review focused on that age range. And late adolescents, 15 to 18-year-old, 46.3% of the papers included that age range. This isn't terribly surprising. We see a lot of really popular data sets, network data sets that were collected during this period. So some of you guys might be familiar with AdHealth, which is a US-based data set that includes network data. Many papers were done with AdHealth data. And there are also some European data sets as well that are focused on this adolescent period. It's a really important time as well, developmentally, for understanding things like peer influence. But what's interesting is very few articles included data collected on preschoolers. So if we look at the 0 to 4-year-old range, only around 4% of the articles in my review included kids in this age range. So even though preschool is a really important time for thinking about the development of social relationships, it's a time when kids are kind of first foraying out into the world and developing these relationships, there aren't very many studies that are looking at kids in this age range. We can also think about what types of relationships tend to occur in these studies. And most of the articles included data on positive ties. So friendship networks were really popular. 55.2% of the articles focused on those. The other most popular type of relationship that people look at are affiliation ties, usually hanging out ties. So who hangs out with who? Around 40.8% of the articles looked at those types of ties. And again, very few articles included data on negative ties. So there were only 4.5% of the articles that included data on dislike ties, and even fewer that included data on aggressive behaviors or bullying type ties at only 1%. So again, we see this sort of skew in the literature, sort of a focus and bias towards looking at positive ties rather than negative ties. There might be good reasons for that. It's oftentimes much harder to collect data on negative ties among kids. Schools tend to be very leery of this. They don't want you to ask questions of kids about who they dislike or who's aggressive towards who. So that might be a piece of why you are less likely to see these. But they're also important developmentally to understand. It's important to know about these negative ties. And interestingly enough, 90.6% of the articles, almost all of the articles, only assessed one type of network tie. So we see very little focus here on multiplexity, and we don't really have a lot of information about signed networks at all. So we're pretty limited in that respect. We can also think about how network data are collected. And here in developmental science, as is probably true for most social network research, even among adults, most of the articles collected data via self-report. So they tended to use a self-report name generator method, 76.1%. There are a few studies that also use peer report type measures, things like social cognitive maps or cognitive social structures, but it was pretty common to use self-report here. So the state of the literature here in developmental science, there's a heavy focus on adolescents. There's a pretty heavy focus on positive ties. And the tendency is that researchers tend to use self-report methods. And that means that the literature somewhat neglects preschoolers. So we see very few studies of young children. We see very few studies of negative ties. And we also see not that many studies are using alternative approaches, things like observation or archival methods to collect network data. So I want to talk about some key challenges to this, why we might see few studies of preschoolers, few studies of negative ties. And I also want to, in the process, try to present some solutions to this, things that developmental researchers might be able to do in the future to collect these type of data. So the first key challenge is, and I can attest to this having done some research with young kids, is that network data is really hard to collect in preschool compared to other age groups. And I'm going to present a potential solution here as well, scan observation methods. So I first want to talk about the challenge to collecting network data within a preschool context. One of the challenges here is that common self-report methods, those methods that everybody seems to be using, where we kind of ask kids who their friends are, who they hang out with, are really developmentally challenging for very young kids, for 3- and 4-year-olds. You can't just ask a 3- or 4-year-old who their friends are, because developmentally, they're still kind of developing self-other and other, so it's not as easy to just kind of ask them questions that we might ask an adolescent. It's not that you can't do it. So there are ways to use self-report methods. However, they require a lot of extra supports. So McCandless and Marshall, for example, back in 1957, developed a technique that used pictures. So if you have pictures of all of the classmates in a child's class, you can use that and you can have kids kind of point to who they like and who they dislike. You can have them sort those pictures. And that actually does work. And there have been people that have used that technique. But it's difficult as a researcher, right? You have to be able to obtain pictures of all the kids in the classroom, which you might not be able to do if you don't have permission. And so there's some challenges to being able to use our standard self-report methods with these kids. So a potential solution that's out there are to use observational procedures. And so for young kids, observations may be the easier way to collect network data. And I'm going to talk about scan observation procedures, and in particular, some of the scan observation procedures that were developed by Laura Hainish and colleagues at ASU that have been used to generate social interaction data that can then be converted to network data among preschoolers. And just to give you an example of what this looks like, basically in a scan observation procedure, you have a trained observer, and that observer, before they go out in the field for the day, receives a randomly ordered list of children in the classroom. And they're going to start with the first kid in that list, and they observe that kid for a 10-second period and code their predominant behavior. And the Hainish method has 7 behaviors. So social play, parallel play, rough and tumble play, and onlooking behavior, which are all social in nature. And then there are some behaviors that are a little less social in nature. So there's solitary play that's not social at all, and unoccupied behavior where kids are just sort of staring off into space, which happens more often than you might think. And then there's teacher-oriented behavior where it's social, but they're mostly just engaging with their teacher. So you're looking at the kid for 10 seconds. That kid might be engaged in a couple of these behaviors, but you're going to code the predominant one, the one they're engaged in the most over that 10-second scan. And then if you code something that's a social interaction, so social play, parallel play, rough and tumble play, or onlooking behavior, then you would also code all the identities of the peers involved. So you'd have sort of IDs for those kids and you'd record those. And then move to the next child on the list. Such that by the end of a scan observation period, an observer would come out with many of these scans of kids kind of observed in different behaviors, some of them social, some of them not. But they'd have among those behaviors a bunch of social interactions, right? Social play interactions, parallel play interactions. So I'm going to talk about some data that I collected in this way. These are longitudinal data. They were collected some time ago now, pre-pandemic, between October 2012 and May 2013. We had a really great group of trained observers. They were out in the field Monday through Thursday observing these kids. Fridays were a little weird in these classrooms. The activities were a little different, so we didn't code on Fridays, but most days of the week we were out there. And they coded indoors and outdoors during unstructured periods of free play. So we had these guys out, the observers were out a lot. They were observing the kids in lots of different types of settings. This is really like intensive data collection. So we were only in 2 classrooms. We had a 3-year-old classroom and a 4-year-old classroom. And these are both in the Midwestern United States. And again, the curriculum was largely play-based. So for the most part, for most of the day, the kids were just sort of involved in free play and were able to kind of pick and choose activities and who they were engaged in those activities with. So across this period, we ended up with a lot of different observations of social interactions. So in our 3-year-old classroom, we had 434 parallel play observations and 668 social play observations. In our 4-year-old classroom, we had 423 parallel play observations and 994 social play observations. And we also conducted reliability assessments on a subset of these. So sometimes we would have 2 coders out coding the same set of kids. And we had decent reliability on observed behaviors, so 79.8%. And on the number of play partners for any social encounters, so 81.9% there, percent agreement. So we have all these social interactions that came out of this observational data, but there's sort of still a challenge here, right? How do you take all of these observational data and then turn it into a network? And this is where the second challenge comes in, that it can be really difficult to infer positive and negative ties from these observational data. And the solution I'm going to talk about today for this is bipartite backbone projection models. So just to talk about some of the challenges with these data and trying to infer networks from them, I want to really talk about 3 big issues. So the first is with positive relationships, you have all these interactions that kids are engaged in, but it's a little uncertain how many times 2 kids should be observed interacting with to count as a positive tie, right? So we have all these times we see them playing, but how many times do we need to see 2 kids playing to say, like, these kids really kind of have a relationship, right? Are 2 times enough, 4 times enough, 8 times enough? It's a little bit challenging. And researchers have taken different approaches to this. I've taken different approaches to this. I've never really had a very satisfying solution. Usually we're working on sort of threshold-based inferences here. Another challenge that we have is that directly observable negative ties are low rate and they're disrupted by teachers, thank goodness, right? And so if kids start to engage in something that's really directly observable, like aggressive behaviors, teachers are going to disrupt that really fast. What that means is that if we use a scan observation procedure, we're not really able to observe negative things happening. And you could see from the scan observation procedure that I just showed you, there weren't really any negative behaviors that were coded for. And even if there were, even if we were kind of looking for aggressive behaviors, we'd be unlikely to see very many of those. And so using observational approaches, it's still really difficult to find negative relationships. More subtle negative ties, things like avoidance, right? Where kids maybe are just kind of avoiding each other. That's also really hard to directly observe. So we can't really, if we never see 2 kids playing together, does it mean that they're avoiding each other? Does it mean they have a negative relationship or not? And so these observation methods are a little bit challenging for looking at negative ties as well. And what I want to do with sort of the last part of the talk here is talk about a paper that I am collaborating with Zach Neal on and Emily Durbin, who's they're both colleagues here at MSU, where we are attempting to infer signed networks from preschoolers' observed parallel play and social play. Yeah, these papers are, Francisca just tweeted that these, or put in the chat that these are available on my website, and the preprints actually up on Site Archive. And because it's a preprint, I would love any feedback that you guys have on these methods. So I'm going to talk a little bit about the solution to these challenges with inferring data. So network data basically collected via these scan observations. If we think about the type of data that we're getting back, it actually can be organized as a binary child by event matrix. And so it's a bipartite network. So if you think about the data that comes out of these scan observations, you've got play events and you've got children who are observed in those play events. So when we organize the data, we can have children in the rows and play events in the columns. And for example, in this case, we can see that child A and child B were playing together in play event 2 and play event 3. So this is how the data can get organized. And because it's bipartite, what that also means is if we multiply that network by its transpose, if we take that network and multiply it by the play event by child matrix, we get a co-occurrence matrix. At the end here, we can see that in the co-occurrence matrix, the child A and child B were observed twice together in play event 2 and play event 3. So these co-occurrence matrices are interesting because they can be analyzed using bipartite backbone projection models. Backbone models have become popular for taking a valued co-occurrence matrix and extracting the underlying backbone of that network. And there are several different types of backbone models out there. There's also an R package that was developed by Rachel Domagowski, Zach Neal, my collaborator on this project, and Bruce Sagan that you can check out. That's available in R. And there's several different types of backbone models, but the one that I'm going to be talking about today is the fixed degree sequence model, or FDSM. It provides a statistical test for whether the number of times two children were observed playing together is larger than expected at random. That would suggest a positive tie, or smaller than expected at random. So when it's smaller than expected at random, it's suggestive of maybe a negative tie, like maybe these two kids they're playing together a lot less than you might expect by chance. So that would give you a sense that maybe they are kind of avoiding each other. And just to give a little overview of what this model is doing, the FDSM uses a Monte Carlo method. So what the model does is it's going to construct a random bipartite network. That network is going to have the same row and column sums as our observed child by play event network. And then from that random network, we can construct a random projection by multiplying the random network by its transpose. If you repeat this many, many times, what you get is a distribution. And that distribution allows us to compare and do some significance testing. So we can take that distribution and look at our observed value of how many times two kids are playing together and significance test and see, is it larger than expected at random? Or is it smaller than expected at random? So we actually get a significance test that allows us to create a signed network. But the question here still is it valid? Like, can we use this with preschool kids and play events? In our paper, we wanted to kind of take a look at the FDSM and see, are the networks that are inferred from the FDSM, are the structural patterns in those networks reasonable? Do they sort of match theoretical and empirical expectations in the early childhood literature? If they do, that might give us some initial sense of whether these methods are sort of valid for this type of network. And we did this by looking at a couple of different things. We looked at gender in play and also types of play. And I'll talk a little bit about both of those. So I'm going to start with gender in play. So among all kids, and you saw this in the sociogram of the fourth graders that I presented earlier from Helen Hall Jennings and Jakob Morano, we know that gender heavily structures play. And this is true also of preschoolers. So even by preschool, gender very heavily structures play such that positive ties tend to occur between same gender peers. And we see in preschool, kids have direct preferences for same gender peers. There are also indirect reasons why kids might end up playing with same gender peers. So they're sort of socialized to have gender typed play. So boys might be more likely to engage in things like sports, whereas girls might be more likely to engage in things like pretend play, and because of that, they end up playing with same gendered peers as well. So we see gender homophily in positive ties. And interestingly enough, we also tend to see gender heterophily in negative ties. When kids are asked who they dislike, they're more likely to nominate opposite gender peers. And so this is a well-known kind of finding in the early childhood literature, both in things like friendship studies and non-network studies, but also the small number of network studies that do exist. So we know that our networks that are inferred using backbone models, if they are kind of reasonable, we should see gender homophily in the positive ties and gender heterophily in the negative ties. So what do we see? Here I've got our 3-year-old classroom, and on the left here, I have the sociogram for our inferred signed network. And just to orient you to the sociogram here, green lines represent positive ties. The dotted red lines are negative ties. The pink nodes here are girls, the blue nodes are boys. And what you can see visually here is that we do seem to see some gender homophily in the positive ties. Girls tend to have positive ties with other girls, boys tend to have positive ties with other boys, and the negative ties seem to kind of cross gender, right? So we seem to see some negative ties as red ties going across gender groups. And if we actually look at the underlying data here, that's exactly what we see. So the majority of positive ties are occurring in same gender dyads, 89.7% of them. And the majority of negative ties are occurring in different gender dyads. In a Fisher's exact test, this is a significant difference here. So what about the 4-year-olds? 4-year-olds look similar here. So we see a similar pattern where the majority of positive ties are occurring between same gender dyads, and the majority of negative ties are occurring between different gender dyads. So this is at least promising. There's some initial evidence here that the networks that we're inferring look the way they should, based on what we know about gender and play during this period. But we also wanted to look at types of play here. So if you remember, in the data, we collected 2 different types of, well, we actually had 3 different types of play. We had parallel play, social play, and rough and tumble play. Rough and tumble play didn't tend to occur very much in our networks. This is another thing where the teachers tend to disrupt rough and tumble play really quickly. We did have enough parallel play and social play observations to kind of look at these 2 types of networks separately. And again, just as a refresher, parallel play involves passively participating in the same activity as nearby peers without conversations or interactions. So basically, if you take a look at this picture on the right, we've got these kids are all playing cars. They might be playing next to each other, but they're not necessarily like interacting with each other or having a conversation about the cars, and that would be parallel play. Social play, in contrast, involves actively participating in direct interactions with peers, such as conversation, sharing toys, pretend play. These kids, it kind of looks like they're playing tag or something. So there's direct social interaction and social play. And we think about these types of play. One thing we might expect would be different between them is structural balance. So structural balance, of course, is important in signed networks. Most social networks tend towards structural balance, especially social networks that involve coordination. What that means is in the network, if the product of the sign ties within a triad is positive, we've got structural balance. And basically, social play, because it's active, because it involves more coordination, we might anticipate that those networks would have more balanced triads than parallel play. Balance may be a little less important in parallel play because those activities don't involve a lot of social coordination. There's not a lot of social interaction necessarily going on between the kids. So we looked at that in these networks, and here are the results. So we have balanced and unbalanced triads in the 3-year-old classroom for parallel play and social play. And what you'll see here is that the 3-year-old networks inferred from social play were significantly more balanced than the 3-year-old networks inferred from parallel play. Balance was important in both of these networks, but in social play networks, it was really important. 92.4% of the triads in those networks were balanced. Similarly, we see a similar pattern for the 4-year-old networks. So 86.3% of the triads in the social play network among the 4-year-olds were balanced as compared to only 76.2%. And these results were significant using a Fisher exact test. All right, so I'm gonna quickly wrap up here, but a couple of things for what this means. Well, we have some evidence that preschool networks inferred from backbone models exhibit structural patterns consistent with theory and with empirical findings. And there's initial evidence of validity here. So we see patterns that we might expect in terms of gender. We see patterns we might expect in terms of structural balance, but a lot more work is needed on this. Clearly, this is only research on 2 classrooms. So we need more work to see if these findings generalize beyond these 2 classrooms. And it would also be interesting to compare the results of these networks inferred from observation to self-reported signed networks. There are some people who have done work on self-reported signed networks in preschool. We didn't have these data, but it would be really cool to have both types of data and to be able to do a comparison. And before I wrap up today, I just wanted to put a plug in for some next steps. So more research is really needed on young children's networks. We don't have a lot of research on young children's networks compared to older children. And more research is really needed across the board in developmental science on negative ties. We don't know a lot about negative ties. Some methods that might help, at least for young children's networks, are scan observations and potentially backbone models if we're using those scan observations. And if we end up doing more research here, it can help us understand both the young children's network formation, so really what those processes look like developmentally for kids, and also associations between networks and important outcomes for young kids, things like school readiness or social outcomes for young kids. And I am going to stop there, but please do find me. I've got my website listed here and Twitter. I love new followers. I'll follow you back. Also, I have the links to the 2 papers here. If you have any trouble finding these 2 papers, feel free to email me and I can send them to you as well. And I just wanted to thank my collaborators, Zach Neal and Emily Durbin, who were also really instrumental in the work that I presented today. Thanks.
Thank you so much, Jennifer. I think everyone can clap with their reactions buttons, or you can say something in the chat, or whatever do you feel better to express yourself. So maybe now we are going to go ahead with some questions, comments, suggestions, idea, anything that anyone would like to add. Alice?
Yeah, thank you, Jennifer. This was an excellent talk. And an application that I haven't thought of before. So I just actually came back from a conference about collective behavior that was mostly focused on social behavior of animals that fight and play. And there it's all the rage to use video recordings combined with machine learning to identify ties between animals. And I was wondering whether you see some application for methods like that in observing children, because it seems to be a very intensive process of collecting that data via observation, or whether that's like unthinkable.
Yeah, no, that's a fantastic question. There are some movements towards using video recordings, in particular because, as you can see from this talk, doing the scan observation procedures, right, you have to have a lot of people out there over a long period of time. There's a lot of commitment to resources to do that. So video recording would be fantastic in a lot of ways. It would also give us, in some ways, a lot better data, right? Because we'd have continuous data over time. You could use things like, I don't know, relational event modeling or something like that. But there are a couple of challenges. The main challenge I can think of is sort of ethical stuff. Getting permission from parents to video record might be a lot more challenging. If I think about the school districts that I've worked with, or the schools I've worked with young kids, I don't know that they would allow us to come in and like continuously video record for long periods of time. And if you didn't have permission from all of the parents to video record everybody, that could be a potential challenge. But I do know that there are people out there. So there was a paper that was published recently in Social Development where they were using different video recording techniques. So there was one where they actually put GoPros on kids and had them kind of like interacting and were observing. It wasn't necessarily a network study, but they were using that to observe social interactions. And I thought it was very cool. And that paper was actually a tutorial for how researchers could do that. So there is movement towards being able to use these kinds of methods, and the network data that you would get back in that context would be very rich, even richer than the scan observation procedures I talked about today.
I can see that Ana Lucia raised her hand. Ana, are you there?
Yes, I'm here. Just 1 second. Can you hear me?
We hear you.
Okay.
Yeah.
Congratulations on the talk, Jennifer. I pretty much enjoy it. Well, actually, because I'm also a developmental psychologist working with social networks, and I'm also very much interested in sign graphs. So this was something that I really enjoyed, and I see the tremendous effort and value a lot, like how much you're giving into the field with this type of analysis. I have two questions. One is more methodological and the other is more about like your experience. So I'm going to start with the first one, and it's related to what you just mentioned about getting permission from the parents. So this type of work has the unique, I would say, aspect as opposed to like work with adults, where you have to spend a lot of time building like rapport with the school, with the parents, allowing people to trust you as a researcher, that this is important and that this is something that will, provide future recommendations in science. But I know how hard that is. So I wanted to ask you about your experience in engaging with this schools, with this parents, and how did you do to build a strong enough relationship for them to let you in to this space of observing their toddlers. And aside from that, my second question, which is more methodological, is about negative ties. And in this specific developmental stage, I was wondering if you did some observations about aggression versus dislike. What is the difference between an interaction, for instance, biting a kid, which would be assumed for some researchers as an aggression? Is that a negative tie, or is that an interaction across time? How many times do you have to like fight another kid or not in order to consider that a negative tie? Or if you see some concurrent negative and positive relationships in longitudinal data, because in my lab currently, I'm now working with adult populations at the time, but we see that with longitudinal data, we find some overlap with what we call negative and positive ties at some point, depending on how we code them. If these were like interactions or if these were like relationships. And I'm going to pose an example, and it's like, do you dislike this person as opposed as have you hit this person, right? How do you handle that? Did you observe that in your data? And what would be your recommendation for this specific type of methodological finding? Thank you so much. It was a great presentation.
Thank you so much. Those are really thoughtful and awesome questions. For your first question, yes, so any type of network data within school contexts, it always starts with having to build relationships. The preschool data that I collected, I actually was a little bit spoiled with that because I was working in a university preschool. So that preschool already had sort of expectations that there might be researchers kind of coming in to do work, and they were already set up to really have really good observational kind of facility. So there were one-way, I didn't sort of mention this, but there were one-way mirrors where observers could sit behind those one-way mirrors and observe without the kids really being able to see them, which you wouldn't normally have in a preschool setting. But because this particular school was sort of set up as a university preschool, they had this kind of expectation that researchers would be kind of coming in and observing. That said, even though that was the case, we still had to sort of negotiate with the preschool. In particular, we initially wanted to do some work where we were also going to talk with kids about who they liked and disliked. And the preschool would not allow us to ask any questions about dislike. They said, we won't allow you to like ask questions about negative relationships. We just don't, our philosophy is that we don't want to like and bring kind of negative relationships in with the kids. And so we respected that. We didn't do that. We did do some interviewing with kids and ask them who they were positively related with. But even that, we didn't have the pictures. And so the data was not, the self-reported data that we got back, I would not trust as like strong network data. Most of the time when we were interviewing kids, I'd ask them like, who do you like? And they'd be like, oh, it's my birthday tomorrow. And it was like very hard to keep them on track. So I think the observational data was much better. But with older schools, so when I worked in elementary school contexts, oftentimes I'll spend a pretty long period before I even engage in research, just out in the school and spending time trying to get to like learn about the school context. So when I've done this work in elementary schools, for example, I've spent a lot of time building relationships before I even sort of talked about doing a network study in those contexts. So it is a little different in that respect. The other question about aggression and dislike was a really good one. So in our study, we did try, in addition to the scan observational protocol that I told you about, we also tried to have event observations. So while our observers were out there, if they did observe any sort of aggression, to indicate that and who it occurred between. It was so rare that we would get back any sort of event scans that we weren't really able to use that data. And so that was one of the problems we had with observations of aggressive behaviors. It's occurring, it's just that it's hard for observers to catch. And I think that's why we moved in terms of thinking about these negative ties. Aggression's important, but we sort of were kind of also thinking about affective relations and things like avoidance, which are much more subtle and different from aggression in a lot of ways. But we thought, well, maybe with these backbone methods, at least we could infer if like there are kids who seem to be kind of actively avoiding each other, maybe that's an indication of that they at least don't really like each other. And we still need to do more work to validate that, those specific relations.
I think the next question is from Alison.
This was such a fun talk. Thank you for giving it. I was thinking about how important teachers are. Teachers are important in mitigating these negative relationships. And I'm just curious if you have the data to see whether or not the network changes in response to a different teacher for these kids. Yeah.
Yeah, that's a really interesting question. So part of the problem that we had is that the data collection was so intensive, we were only in 2 classrooms. So we only have 2 teachers to compare. It turns out those teachers were pretty different in their style. So I think like if we had more teachers, it'd be really interesting to look at like how teacher interactions might impact these networks. And they definitely do, right? So some teachers are much more like hands-on and sort of structuring relationships in the classroom, whereas others are more hands-off. We do have data. So the data that I showed you was from 1 year of data collection, but we did some pilot data collection. So our 4-year-olds, we have some information about them the prior year in a 3-year-old classroom with a different teacher. So there's some potential, like on a very small scale. We haven't done this, but we could look to see like how did their relationships kind of change. There would be enough of them that kind of crossed over. There was stability in that year between one teacher to the next. Because I do think that 3-year-old teacher in particular in the school was like very kind of good at knowing like about the peer relations in her classroom and kind of how to structure things and when things might be going awry. And so it'd be interesting to see when they switch from that 3-year-old classroom to the 4-year-old classroom, what the changes look like there.
I think you have a question, Dino. Yeah.
Yes, so thanks for your very interesting talk. And I'm also very interested in science networks. So it's really interesting to look at your different applications. I think I have done some very similar work, but in a very different context where we are looking at the relationship between products, including complementary relationship and substitute relationship, and also from the bipartite network of product and baskets data. So I have a question regarding the choice of the kind of the network model you use in the backbone extraction from the bipartite networks. I wonder like if there is any background or theoretical motivations to use these kind of fixed degree kind of thing. Is it reasonable to assume like every activity or every children have a fixed number of participation?
Yeah, so we picked the fixed degree sequence model in particular. We were interested in making sure that the marginals were sort of controlled in these networks. So there are some kids who potentially might kind of engage in lots and lots of play events. And there are some play events that tend to have a lot of kids in them. And so what's nice about the fixed degree model is it is sort of taking those things into account when you're building those simulated networks that then go into the null distribution. So it accounts for like whether certain play events have lots of kids in them, which might mean that like 2 kids being observed in that play event, that's not as meaningful as if it's just 2 kids playing together. And then also there are some kids that are just like really social. So they like play with everybody and they might be observed in a lot of play events. And so we also kind of wanted to control for that. And so that's why we picked that particular model. But you're right that a lot of different models exist.
I'm wondering like, have you tried other models and what they compare with each other in terms of the results?
Yeah, we haven't yet tried any of the other types of models, but that would be something that we could do. My collaborator especially is like, that's kind of one of his main areas. So I'm sure he'd be really interested in comparing across different types of models and kind of trying to see what those differences might be between the networks inferred from one to the next.
Thanks.
Hi, Jenna. Thank you so much for that talk. It was very, very interesting. I was just wondering if you have looked at other methods. You said you used some stochastic actor-oriented models. Have you considered, maybe also in the context of what Alice was talking about, animal networks, relational event models are quite popular to look at how likely it is that these children interact in a positive or a negative relationship with each other.
Yeah, I haven't used relational event models. Honestly, I wasn't sure if the type of data we had would be reasonable for those types of models. The main thing is that they're sort of scan events. And so they're not necessarily sequential in the way that I think that you might want for a relationship.
I was thinking, you said that you observe things 10 seconds at a time, then it sounded to me like it might have been, but maybe it's not. Of course, I don't know what the data looks like, so that's a very valid point. But if you observe them at 10-second intervals, I was thinking maybe that means that we have sort of something moving along a time scale relation as events should be ordered, basically.
Yeah, they could be. The issue would be that the 10 seconds, so the kids are sort of like randomly ordered in a list. So you might be observing one kid and like a play event, and then you'd switch to another kid that might be like in a different grouping. Yeah. And so that the time event, the temporal ordering is not necessarily as like fluid as you might want. I think the techniques that Alice was talking about would be like perfect for relational event modeling, right? Because you'd have, if you had a video, then you would have a view of everybody interacting with everybody over time.
That's true. That's good.
Yeah.
So I also was thinking when you were talking about this, trying to find an automatic way of logging or videoing. I don't know if you're aware of the Swiss Student Life data set, that they had like these little necklaces on the students, and they observed it over years, and they sort of automatically logged who the students were interacting with over a time period.
Yeah, so that.
But of course, then. No, sorry, please continue.
That's a direction actually that I've been really interested in. And I've been working with an engineer here at MSU over the last couple of years on another project that would also be with the younger kids. But he is very interested, he's developed sensors that allow you to track kids' proximity, but also whether they're sort of oriented towards each other, and to track the voice as well. Clearly that's very intrusive in a lot of ways. Yes. And so you had to kind of find the right classroom where you'd be able to put these on kids and get permission.
Yeah, that's the thing, it's kids. You seem to, I mean, it's hard because it's kids. You have to very limited options of how to gather your data. I completely understand that.
Yeah, but I think it's a really cool point. And the idea of having like sensors or badges, that would be an ideal way to collect these data, again, because you'd have richer data than what the scan observations would even allow, right? And better temporal ordering.
No, thank you. Thank you again. It was a very nice talk.
Thanks.
I can see one more hand raised.
Hi, Jenna. This is Gursharan here. Thank you for a lovely talk. I have a question regarding this recent COVID lockdowns that we saw for schools as well. Did you see any impact before and after this lockdowns? Because from time to time, we have been seeing that the schools are closed for some time. And then I suppose it's hard for the kids to make friends again, and like they have been spending a lot of time at home and then going back to school for a few days. Did you see any such impact of these things?
Yeah, so our data were all collected pre-COVID. However, I do think from talking with other peer relations researchers that are doing work pre and post-COVID, that there have been huge impacts to kids not having, the time in the classroom. So I think you're absolutely right that there are impacts of COVID. The other impact we see for research is that it's just been very difficult to do this type of observational research post-COVID, right? Schools, for good reason, don't want a lot of people entering into classrooms that don't need to be there. And so doing these observational methods is more challenging post-COVID. And while COVID is still active and we're still in the middle of a global pandemic, it's much harder to gain access to schools than it used to be, even though it was difficult. Then too.
And instead of the sort of, you used a fixed degree model that for analyzing your distribution. Do you also have fixed degrees for your groups? Like you mentioned that the gender plays an important role. So when you take the row totals, do you take row totals for all the students or for gender specific groups?
Yeah, so the fixed degree sequence model, we were using sort of the marginals for each kid and then the marginal for the different play events. But we didn't necessarily do it by like different genders, right? So that would be sort of a different type of model, but could be interesting to look at.
So that could fall in this block structures. I've worked on the stochastic block models, where in a network you have different blocks, each block representing one specific property or the characteristics of the people. It could be gender, it could be an income group, income specific group. So in that aspect, I was thinking if you looked at the gender specific groups.
Yeah, that would be really fascinating to do. We have not done that.
Okay. Thank you.
Thanks. You have a lot of questions already. It was a very interesting talk and everything works out really well. And I think you already leave your Twitter account. So if anyone wants to make more questions in the future or would like to suggest anything or read your articles, I think all the links are in the chat. So thank you very much again, Jennifer, for doing this. And thank to all the people who are in here right now. Next week, we are going to have another speaker who is going to be actually Miranda Lubers, who is going to be talking. It's going to be a different kind of WIN seminar because it's not going to be about a specific research, but it's going to be pathways. So it's a new kind of WIN seminar that we are trying to put in there, and she's going to be talking about her pathway through networks and how has been everything doing research and that kind of stuff. So it's going to be super interesting. So looking forward to see you all in there. Thanks.
Thank you all.
Thanks, Jennifer.